You're live.
Thank you.
All right, welcome to our third session this afternoon. We have with us today Maya Natarajan, who will be speaking us another somewhat provocative title, the rise of graph jobs and the disappearance of graph technology. I'm shocked to learn about the disappearance of graph technology. We look forward to hearing about this.
All right, thanks, Mike. Hi, everyone. My name is Maya Natarajan, and I'm the founder of Node to Node, a consulting firm that helps graph technology companies like Neo4j and MemGraph take their product or technology to market. So what I'm going to do right now is I'm going to start off with a study that Amy Hodler, a colleague of mine, and I did late last year, and looking at the state of the graph. Okay, so for this particular project, we interviewed over 30 people across different walks of graph life. We interviewed graph vendors, graph services companies, graph analysts, graph influencers, and graph customers. By that, I mean organizations that have implemented graph. Okay, and these are the three main takeaways we took from we gleaned from that particular study. The first takeaway is that graph has not yet crossed the chasm. You know, this is interesting to us and surprising because graph has been on the market for over 20 years now, and you know, really graph solves some very specific, unique cases, use cases, right? So that came as a surprise to us. The second takeaway we gleaned from this particular study was that a graph database is not really necessary. Now, over 2/3, or I want to say over a majority of our interviewees all echoed this particular sentiment. And the last takeaway that we had from this particular study was that the uptake of graph analytics, and specifically here we're talking about graph algorithms, is still very low. And this despite major education by, I want to say, all the graph vendors, but specifically by Neo4j, right? So all these were the, you know, the three takeaways that we took from this particular study. And so, you know, the interesting thing is, over the last 9 to 12 months, we've seen a sharp increase in the number of job postings for graph skills. And here I'm specifically talking about the graph engineer or a knowledge graph engineer. Okay, and so this is, and it's interesting because while the adoption of graph has been very low, we still see that that sharp increase. So here, all the major graph vendors, you know, such as Amazon, Microsoft, and Neo4j, as well as newbies like Nebula Graph, are looking for graph engineers. Okay, as are graph services companies, Accenture, Deloitte, Graphable. You know, all looking to hire graph engineers. And last but not least, we have graph customers: Pfizer, AstraZeneca, Randstad, Netflix, Airbnb. I've just got a small number here, but there are a number of graph customers looking for graph engineers, specifically the knowledge graph engineer, right? So there is definitely a paradox. You know, we see the rise of graph jobs does not correlate with where the state of graph is today. So really, what gives? Well, Amy and I also looked at the three trends that are propelling graph back onto the main stage. And these three trends are: one, the explosion of Gen AI and LLMs. And of course, you know, unless you're under a rock, everybody knows this, right? So this is not surprising at all. The second trend is the notion of hybrid architecture graph databases for more efficient processing, okay? And I'll get a little bit more into that as we go on. And then the third is the idea of a standalone graph analytics engine on top of any database. Okay, the two trends at the end, trend number 2 and trend number 3, are innovations in the graph world. And those are what I think are more exciting, because they're really, they're not thought of right now because we're all focused on Gen AI and LLMs, but those are the trends that I think will be pushing graph as we go further along in the timeline. All right, let's take a look at each one of these in greater detail. First, the explosion of Gen AI and LLMs. The world is abuzz with Gen AI LLMs, right? And rightfully so. I mean, Gen AI LLMs have the ability to generate content, images, text, video at the back of a simple natural language prompt. Okay, it's that powerful. However, of course, Gen AI LLMs, you have to be a little careful because they have a lot of potential risks, basically because of the probabilistic nature of these models. Okay, the first risk, of course, is Gen AI LLMs hallucinate. Okay, they generate content, but they can generate false information that may look plausible, but is not, because it's not based on input data or even reality sometimes. The second risk that you have to worry about is that Gen AI LLM models lack transparency and explainability due to the black box nature of these models. And last but not least, Gen AI becomes outdated because these models are trained on data that they're initially exposed to. And of course, over time, the data becomes outdated. And the only way to update that data is to retrain the model, which is both time and resource intensive, right? So given that Gen AI models are, Gen AI LLM models are super powerful, but they come with these potential risks. How can we take advantage of them, right? And of course, I'm here at the Knowledge Graph conference. What am I going to say with a knowledge graph? A knowledge graph captures domain-specific information, and so provides real-world context. And it's this real-world context that grounds Gen AI, LLM models, that reduces hallucinations and provides more transparency and explainability of these models. Okay, so what I'm going to do right now is, we've got the context. How can we use that context that knowledge graphs produce, right? So what I'm going to do is take a look at LLMs without just LLMs alone, and then LLMs plus a knowledge graph, and see how context plays a very important role. Okay, so when here you have a large language. Here we have large language models. When large language models or LLMs are used alone, what happens is it takes a user's prompt and it generates a response based on the data that it was trained on, basically what it knows, right? And so LLMs excel at statistical analysis as well as pattern recognition, but they lack an understanding of the context of the data they process. Okay, so how can we improve the response of LLM models? With a technique called RAG. You've heard so many talks about this in this conference. I'm just going to give a very high overview and try and keep it quick. We all know what RAG is, but what RAG does to LLMs is it enriches it. Okay, and basically a RAG consists of two phases. We have the retrieval phase shown in gold, and then a generative phase shown in blue. In the retrieval phase, search algorithms search for and retrieve information based on that are relevant to the prompt. Okay, so this information that's produced is then enriched with data from external sources. And that external source could be a database. It could be, what do you call it? It could be a website, or it could be a database. If you're looking at a database, of course, it could be a relational database. It could be a NoSQL database. It could be a vector database. You get the drift. It can be, of course, our favorite, a graph database. And so we're talking about a knowledge graph, right? In the generative phase, what happens is that there's this augmented prompt together with its training data is then processed by the LLM, and it generates a response to the user in real time. Okay, so that's how it works. It's basically an augmented response, right? And I was going to say, I know Jesus this morning showed his example. Let me show you a much simpler example. I'm going to use Game of Thrones. And the question is, why Game of Thrones? Because it has, and for anyone who's watched the show, it has complex relationships amongst the various characters in multiple ways, right? So you can see all that context. And I think if I were to show something with a knowledge graph, that really, really shows you how much context there is. Now, what I'm going to do is I'm going to compare, I'm going to showcase this example using an LLM alone. In this case, we use ChatGPT, and then an LLM plus a knowledge graph, okay? And I used a very simple prompt: who has the most skills in the Game of Thrones? And the LLM alone response is that that it's Arya Stark, okay? And it goes on to say very confidently that she's very skilled with the sword and has killed many an enemy throughout the series. Now let's take a look at what the LLM plus knowledge graph response is. And here it says the answer is Daenerys Targaryen. I don't know how many of you have watched Game of Thrones. Yeah, there you go. Big fan, right? And of course the answer is Daenerys. She killed 1,044 people. Okay, so the bottom line is here we're showing a fairly simple prompt, but you have to keep in mind that with this prompt you have to actually traverse one hop to find killed characters and then find the sum, right? And that's tough for an LLM to do. To be honest, I thought maybe the LLM would guess one hop, but these are what we call recursive queries, and where you have 1, 2, 3, many hops, right? And as the number gets bigger, the LLM is not going to be able to solve this problem. And that's exactly where graphs shine. And that's exactly, that's their bailiwick, right? Second nature to them. Now, this is a very simple example, and the LLM failed, but with a knowledge graph, and I say knowledge graph, but I say graph in general, you can easily answer this question, right? And this is the #1 trend that's propelling graph back onto the main stage. But like I said before, that's just one area. And what happens if Gen AI and LLMs disappear? That doesn't mean graphs are going to disappear, right? So I'm going to look at trends 2 and 3, which are both focused on graph technology itself, the graph database or graph analytics. Trend 2 is the hybrid architecture graph databases. Here, I'm actually going to talk about one of my clients, memgraph. And before I go any further, let me tell you what memgraph is. Memgraph is a property graph database that has been natively built for in-memory data storage and analytics. Okay, so memgraph has 3 modes of operation based on workloads. The first mode of operation is the in-memory transactional operation. And this is used in applications that require immediate responsiveness. And what's the advantage of this? This means that you get high performance because it's done in memory with low latency. Okay, what is the disadvantage of this is if you have you have a limited availability of RAM, and so if you have extremely large data sets, obviously this mode does not make sense. The second mode is the in-memory analytical mode, and it's used for concurrent execution of complex analytical queries. Now, what's the advantage of this mode? It's speed. What's the disadvantage of this mode? Again, keep in mind this is in memory, so if you have extremely large data sets, this is not, it's going to be limited, right? There is another disadvantage. There are no asset guarantees in this particular mode, and so if you had, if your server crashes, for example, you're going to lose data. So to get around this, what memgraph has done is they allow for manual snapshotting, so that you lose a limited amount of data, but the fact of the matter is you will lose data if you're in this mode and your system crashes. The third mode is this on-disk transactional mode, and this is used when you have extremely large data sets. And the way it works is you have cold data and hot data. So, cold data is identified and moved on to disk. Could be SSD, could be HDD, and so what happens is transactions always have immediate access to hot data whenever they need it. The advantage of this is, of course, scalability, but then the disadvantage is there's a trade-off, right? You get scalability, but your performance is reduced, and so the performance is reduced. What I wanted to end this particular trend with is that with these three modes, what memgraph has done is you get high performance, you get scalability, and you get speed with low TCO. So trying to get the best of all worlds, right? All right, the next trend I'm going to talk about is the standalone analytics engine. And there are not many companies. There are a few companies looking at this particular mode, and some of those that you're familiar with, maybe relational AI and PuppyGraph, and I think Waymo is somewhere here in the audience. There he is. Yes, PuppyGraph also has a standalone graph analytics engine. What I'm going to talk about is, again, I'm going to talk about memgraph because they too offer this mode. And if you recall in my previous slide, I talked about an in-memory analytical mode. That was the second box. In that mode, that mode doubles up as a standalone graph analytics engine when you're using memgraph. So let me just quickly walk you through how this works. The first thing you need to do is start memgraph in analytics mode, and once you've done that, you then import data from wherever, whatever the source is. You bring in data, and you can bring it in really quickly, very quickly and very efficiently, because as I said earlier on, this is the mode where there are no ACID guarantees, and so there's you can quickly import the data because of that. All right. Once you have it in there, of course, you want to perform the analytics, and memgraph, as I mentioned earlier on, their query language is Cypher, and so they've optimized Cypher to a great extent. Not only are Cypher queries really quick because it's done in memory, but they've also built in graph algorithms. Specifically, I'm talking about deep traversal algorithms like BFS, DFS. All shortest paths and many others within the core of the engine, and so their performance is also enhanced. Okay, so once you've got the analytics done, you have your results, and now this is where the fun part comes. You can export those results out to any database. S3, what else is there? Snowflake, Postgres, Neo4j. And I always say, you keep it in memgraph, right? I've given you choices of whatever database that could be. And then once you're done, of course, you can shut this mode off, and the memory is transferred back to in-memory transactional mode, and you can do your transactions there. Okay, so with this, you can see it's very clear. You have your compute mode that's separate from your storage mode, and that's how memgraph allows for a standalone graph analytics engine. Okay, and this is exactly how one of their customers, Sayari, uses memgraph. And I don't know how many of you are familiar with Sayari, but they're basically in the supply chain risk intelligence industry. Now, their challenge was to find hidden risks in a ton of data, 50 billion records covering 640 million companies, involving over 600 million individuals. Okay, so what did they do? They've deployed a memgraph knowledge graph of 2 billion nodes and 7 billion relationships, and they use that to uncover hidden risks in with universal beneficial ownerships, UBOs, within their corporate and trade networks. Okay, and they use memgraph in this in-memory analytical mode only. And what they've seen is that their results are stunning. They can query over 16,000 queries, and with most of those, 99.8% of them processed under 10 seconds. Okay, so they managed to find their hidden risks efficiently and really quickly, right? and as using memgraph as a graph analytics engine only. Okay, and so with that, I'd like to finish my talk very quickly by saying, and I have 13 seconds. I started off with the dire state of the graph, right? But I want to say I'm super optimistic, especially we've only been, 5 months since we did the study. I'm super optimistic that, the trend for graph usage is going to start rising again. And I believe that at some point in time, graph will clearly cross the chasm. So with that, I'd like to thank all of you, and I'm open for any questions. Thank you.
So let me start with the question, because you started out saying this really provocative thing that we didn't need graph. So can you just clarify a little bit? Was your point that up until now we had less need for it, but now with the
no, not that we have less need for it. Okay. I think it's there is a need for graph, but it's just that organizations are, it's interesting. They've been around for so long. You'd think by now, hey, we know exactly what use cases we can use graph for, and we can easily incorporate it within our organization. But the thing isn't that graph isn't important. I think it's really splitting out the graph database from graph analytics. And, like I said, we interviewed over 30 people from the different, the different types, right? A lot of them just said, hey, we don't need the graph database. It'll be nice if we can just have graph analytics.
Yeah, it's definitely the case that a lot of people who are building graphs are failing to exploit, being able to do, a lot of the graph analytics stuff.
Yeah.
That's for sure. So,
yeah.
Other questions for Maya?
Thanks a lot for the talk. So is there a potential to repeat the study maybe, and how much effort does it take to do this kind of study? Because I feel like the results may be very different at the end of this year as opposed to the end of last year.
So you bring up a good point. Amy and I are going to do this every year. We just started it last year, but we are planning to do another one this year to see how things have changed. I think things will change drastically just because of Gen AI and LLMs. I want to see how long that lasts, because I don't want to say it's a passing fancy. I think it's a little bit more than that. I think Gen AI and LLMs have, they're important. But at some point, I think the graph industry needs to stop thinking that there's that one little magic thing. I think we need to focus more on graph technology itself. How do we make that more, more accessible to everybody? I think that's what we need to do as an industry. This is my opinion.
So a quick follow-up question.
Yeah, sure.
What happened to graph machine learning? Is graph machine learning dead?
No, I don't think so. See, if graph algorithms haven't taken off, graph machine learning is another bigger step. And graph machine learning is very interesting and I think super useful and helpful. But unless we've solved the initial problems here, we're not going to be able to get there. Yeah.
Any other questions for online? Okay, good. All right, thank you very much, Maya.
Thank you. There we go.